I don't like school. I hope we have a snow day. Okay. All right. So we are going to be writing the equation given the graph. So it's kind of hard to see because you can read it on the paper, but because of the fact that this is like an old school camera, it's kind of hard to see. But these go by pi over sixes. So this is 0. This is pi over 6. This is 2 pi over 6, 3 pi over 6, 4 pi over 6, negative pi over 6, negative 2 pi over 6, or pi over 3. Okay, so that's what we've got going on. So the question is, what does this graph look like? So if I were to graph this, I would graph this. I would look at the fact that this is either a cosecant or a secant curve, depending on what I decide to choose. So what I would do is I would just draw a quick kind of sketch of what that sine curve would be. Like so. Because that helps me. The second thing I would do is I would look for where are those high points and low points occurring, because my midline is actually going to be halfway between them. So I can see that I have one occurring at -1, one occurring at -5. I'm going to find that halfway point. So what's halfway between -1 and -5? That would be -3. So I know I have a midline at -3. Okay, so if my midline is at -3, my equation right now would be y is equal to -3 plus or minus an amplitude, secant or cosecant. So that's the next step is, do I want to use cosecant? Do I want to use secant? So what I'm noticing is on this y-axis right here, it looks like a cosine curve that's flipped. So hopefully you guys can see that. Usually my cosine curve would start above the midline, pass through the midline, go to the minimum, and then go back up. So because it is flipped, and I don't even have any shifting going on, I can actually think of this as -3 minus, because there's a flip there, and normally I would think of it as the cosine curve, but the reciprocal function for cosine is secant. So minus secant. And then I've got to figure out how to write in the shift if I have a shift. In this case, I don't have a shift, but I do have to think about the period. So to find the period, the quickest way to find a period is to look at one maximum and go to the next maximum, or look at one minimum and go to the next minimum. Now, since my minimum is on 0, it's probably easiest to do that. So it's going from 0 to 2 pi over 3. That right there says 2 pi over 3. You probably can't see it. So my period is 2 pi over 3. And I know that I need the b value in my equation. So I know that the period, which is equal to 2 pi over b, can be written as 2 pi over 3 equals 2 pi over b. And I can cross multiply and solve for b. So when I cross multiply and solve for b, I am going to get 1/3. So I get 1/3 x here. So I use, it could be a sine curve. It would not just be a sine curve. It would be a shifted sine curve. So if I wanted to use my sine curve would be a shift of pi over 6. Okay, so if I wanted to use my sine curve, I would say sine should start here, but it's over here, which means I'm shifting it right pi over 6. So I would have to put a negative pi over 6 in there if I wanted to use it. Is B3. Did I mess up on multiplying? B is 3. 3, because it's 1/3 of the period. Yes, thank you. B is 3. Sorry about that. I didn't really cross multiply, so I should have. How do you know it's secant and not cosecant? It can be either, Lucy. Again, it depends on what you see. I actually, when I plugged it into the calculator, I actually did plug it in just to get my quick sketch. This is what I plugged in. So this equation right here, -3 plus 2 cosecant 3x minus pi over 2, will yield you the same exact graph. So you can use cosecant. You just need to know that cosecant has a shift in there. So you can actually come up with an infinite amount of possibilities as long as you are finding shifts that actually make sense for this graph. So hopefully that makes sense. Sorry, I'm just reading through the chat. What about the amplitude? Did I miss the amplitude? I did miss the amplitude. I'm missing the amplitude. So Cynthia, or who asked me? Cynthia, did you ask me? What about the amplitude? So the amplitude, sorry about that, I missed it. The amplitude looks like it is a distance of 2 above and below. So I should have a 2. And I think I had that in the other one. I did. So sorry about that. The amplitude can't change. So your amplitude is stuck at 2. So yeah, the amplitude is there. So it should be minus 2 secant 3x. Thank you, Cynthia, for catching that. And I forget who, Ayush or Carlos, I can't remember which one said the 3. Okay, so that would be your cosecant or your secant curve. Again, depending. I have, when I give my test and my quiz, I usually come up with about 3 or 4 different equations that I think you are most likely to come up with. And usually I get 98% of you. I can correct it that way. And then there's that 2% of you that are going to give me a different answer that I didn't come up with. That works. So, but yeah, this is a fun one to grade. Okay, so the second one is this one. So I know it's really hard for you guys to see, but I just want to give you that all of the solid lines that you see. So this is pi over 6, this is pi over 3, this is pi over 2, 2 pi over 3. So these go by pi over 6s, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So this is like a 12th. This point right here and this point right here. So if this is pi over 6, this is a half of pi over 6. So this is at pi over 12. So we'll look at it in a second. I just want to give you a minute to kind of decide what you want to do with it. So again, I try to, as best I can, sketch that sinusoidal curve. And I call it a sinusoidal curve because, again, everything, if it's a sine or a cosine, you can just call it sine. Because sine and cosine are just shifts of each other. That is a horrible looking sinusoidal curve. So this is going up by 5s. So this is a 1, this is a 2. So 3, 4, 5, 6, 7, 8. So just so I don't make that mistake again, the amplitude is 8. So I'm going to try to back this up. Sorry. Hopefully that's okay with you guys. Okay. So the amplitude is 8. Not 8. Sorry. What did I say? It was 3. 1, 2, 3. It looks like the midline is right here. And the midline is going to be at 5 then. The amplitude is, the distance is 3 above and 3 below. And you can actually find the amplitude by taking which I'm going to show you in a second. But the amplitude, you can take the max plus the min divided by 2. So another way to think of the amplitude is the max plus the min divided by 2. Okay, if I take 8 plus 2, I get 10. Divided by 2, I get the 5. Okay, so you can actually find your amplitude by taking max plus min divided by 2. So we have an amplitude, we have a midline. I need to figure out what the period of this function is. So the period of the function, quickest way to do that is maybe look at the fact that this right here, that max is at pi over 12. And the next one is at, so this is 12 pi over 12, 13 pi over 12. So it looks from max to max that I'm going from pi over 12 to 13 pi over 12. So that is looking to be like a pi for the period. So if the period is pi, and I use 2 pi over b, I can find my b value. So I'm going to cross multiply and get pi b equals 2 pi, and I will end up with b is equal to 2. So I have an amplitude of 3, a midline of 5, a b of 2, and now I'm looking at, am I going to use the sine curve or the cosine curve? So I see cosine when I look at this function, but again, some of you might just see a sine curve starting here, or a negative sine curve, and think of that. So you could think of it as negative cosecant if you want, or you could think of it as the secant function. So I'm going to look at this one as the secant function. We'll see later what I actually plugged in for the equation. So y is equal to my midline of 5. This time it starts above and then goes low. So I'm going to use 5 plus, the amplitude is 3, secant of 2 is the b value times x. I'm shifting the whole thing right pi over 12, so minus pi over 12. And I have no idea what I used for this equation, so we will look. What did I plug into this equation? So I did this. Okay, yay. This was the one I actually plugged in. You can leave it in factored form, just so you know. What you're going to see is that because I was plugging it into the Desmos app, I plugged it in as 2x minus pi over 6. But notice that 2x minus pi over 6 is distributed, so 2 times pi over 12 will get you that pi over 6. But we have 5 plus 3 secant. And again, I could have done cosecant as well. Okay, but this is what I plugged into Desmos, and then it gave me this. And then I just prettied it up a little bit by drawing in the asymptotes for you. All right, and then we have questions, sorry. So I'm trying to do everything. So you don't have, you don't have to distribute the b value. Just know that if you go to check on your calculator, because I'm going to do some calculator ones in a minute, minus the fact that I don't have my calculator, so I'm going to do the best I can without it. But your calculator, when you find the sinusoidal regression, your calculator, I believe, does distribute. So you just need to know that. Okay, so I have one more, and that is a tangent or a cotangent curve. So hopefully that's good enough. For tangent and cotangent, I'd have to kind of give you an idea of where these points are because it's kind of hard to read. But just so you know, this line right here, this is at 4 pi over 3. So what I did, what did I do? 1, 2, 3, 4. So the grid, you can barely see the grid, but the grid was that this was pi over 3. This was 2 pi over 3, 3 pi over 3, 4 pi over 3. And likewise over here, negative pi over 3, 2 pi over 3, wait, 1 pi over 3, 2, 3, 4 pi over 3, and then this is at 5 pi over 3. So you have an asymptote at negative 5 pi over 3, and you have an asymptote at pi over 3. So this is pi over 3. This is negative 5 pi over 3, just so you know. So if my asymptotes are at negative 5 pi over 3 and positive pi over 3, that's a 6 pi over 3 distance, which is 2 pi. So the period for this tangent curve is 2 pi, okay? So period is 2 pi. So in this case, pi over b is what we use to find the period. Remember that tangent and cotangent have a period of pi, so you're using pi over b. And then we're going to cross multiply and solve it. So when we do that, I think we get b is equal to 1/2, which makes sense because I'm stretching it by a factor of 2, which means that my b value is 1/2 to begin with. So the only other thing I need to figure out is, do I want to use tangent? Do I want to use cotangent? To me, this looks like a cotangent curve because it decreases from left to right. So when I'm thinking of how do I shift it, I could think of it as I'm shifting everything left 5 pi over 3, because again, the asymptote itself is being shifted from 0 to that negative 5 pi over 3. You could also think of it as you're shifting it right by pi over 3. Okay, a shift left, a portion of the period will be a shift right the remainder of that period. So I'm gonna look at it as I'm shifting left 5 pi over 3. So I'm gonna use cotangent here. Okay, so we're gonna do the same thing. We're gonna think of it as y is equal to, my midline is slightly shifted upward. So I do have a midline, and I helped you out here to show you that that midline is at 2. It's really hard to see, but that first number that I gave was a 2. So I have a 2. I'm going to put plus because I'm going to use that cotangent. And then I want to look at, how do I get to that 1 value and that negative 1 value? Well, that 1 negative 1 is now at 5. From 2 to 5 and from 2 to negative 1. So that gives you an a value of 3. So I'm going up 3 to get to 5, and I'm going down 3 to get to that negative 1. Okay, and these are all quartered out for you. I quartered them out. Okay, so this is at, what did I say they were? Pi over 3s. So this is at pi over 6, 2 pi over 6, 3 pi over 6. This is at 4 pi over 6. 5, 6, 7, negative 7 pi over 6, and this is negative pi over 6. Okay, so it's going to help a little bit because now you can see that I'm going to use the cotangent. I'm going to write in that I have a 1/2, and again, I said you don't have to distribute. And then we have that x. I'm going left, which means plus 5 pi over 3. Okay, and so just a heads up, this is actually what I plugged into Desmos when I did it. So I actually used tangent. So I had 2 minus 3 tangent of 1/2 x minus 2 pi over 3. Notice that there's a minus here. That's because tangent does not decrease from left to right. So if I want to use a tangent curve, which usually increases along its domain, I have to say, ooh, I got to put a flip in there. So I could have put the flip in here. I could have also put the flip into both of these if I wanted to. Okay, so just heads up. Okay, you can come up with a different one from me. You just have to be careful because one of the things that I make mistakes on even today is the secant and the cosecant. I will do everything out, but I'll write sine or cosine instead of putting secant and cosecant. So I'll be so focused on that I'm using the sine function that I forget that it's a cosecant that was graphed. So hopefully those made sense. And again, I'm giving these in class either tomorrow or the next day. Jay Lane disappoints me. Why did he say we're definitely going to school? Ayush? I think we can go. I don't think it's going to be that bad. Oh, please. He's got all tomorrow. He's good until I'm driving to school tomorrow, because that's when he did it last year. He waited until I was like halfway to school, and then he called it. It was wonderful. All right. So, okay. So the other part of what I wanted to go over is how sinusoidal functions occur naturally a lot of times. And again, you guys use it a lot in physics. If you've talked about sound waves at all, you see it there. And if you're looking at monthly temperatures, if you look at January to January, you will see some sort of starts low, then goes up, then goes back down, or some kind of sinusoidal curve. And then it repeats its cycle over and over again. You can kind of get an idea of the average monthly temperature over years and years and years. You'll see some kind of sinusoidal wave with it. Same thing with high tide and low tide. You see sinusoidal waves with those every, I think it's 13 and a half hours, 12 and a half hours. I can't remember. 12 and a half, 13 hours, somewhere around there. They have a sinusoidal wave as well. So this is from your notebook. It's on page 24. What you want to make sure you do for the problems where I'm going to ask you to find a model is you want to look at all of your data and you want to find where your average monthly temperatures have your highest amount and your lowest amount. So if you look at the first problem, January 1st gives you your coldest average, which is 24.2. So you want to just notate that 1, 24.2 is a minimum value. July, which it's not really January 1st, February 2nd, March 3rd. I think I said January 1st. It just means month 1, month 2, month 3, month 4. So just be aware of that. And then July, which is the 7th month, gives us our highest temperature, average temperature, which is 56 degrees. So we're in Alaska, by the way. We're obviously not in Massachusetts because our average temperature in July is not 56 usually. All right, so this is what we need to do. We need to come up with, if we were to plot this, it will look like a curved function, something like this, or something similar to that. So if we wanted to come up with our own sinusoidal function, we'll always use sine for this. A plus, or D, I think I use D plus A sine of B times X minus C. This is normally what we have. Our book all of a sudden starts using our Greek letters when we're actually applying these concepts. So just be aware that your book is going to use like all these different Greek letters, kind of like when it did for angular velocity and stuff like that. You can use A, B, C, D if you want. You don't have to change it. But what we need to do is we have to find what is going to be our amplitude, what is going to be our midline. So remember that I just told you that your midline can be found by taking your max plus your min and dividing it by 2. So that's what you're going to do. To get your midline, you're going to take your max plus your min divided by 2. And I have that somewhere. So I have that written down right here. Your max plus your min divided by 2. So your midline, max plus min divided by 2. So in this case, and it's your actual max, so it's your Y values, 24.2 plus 56. And we're going to divide that by 2. And we get 24 plus 56, so 40.1. So that's going to be your D. That's going to go right there, okay? Your amplitude can actually be found by taking your max minus your min divided by 2. So that's what we're going to do. Your max minus your min divided by 2. And I'm sorry above, I didn't actually put the max plus the min. I wrote it out of order. So your amplitude will be 15.9. And I think I had these on the board, these two items, for a while. So that's your amplitude. The next thing that we want to figure out is what is the period? So the period is the units that we're actually going to use on our x-axis, from what to what. So the average monthly temperature. So what would one complete period be? Well, we have 12 months. So the period will be 12. So because this is a sinusoidal function, we're going to think of it as 2 pi over b is equal to 12 and solve for b. So we're going to get b is equal to 2 pi over 12, which is pi over 6. Okay, so this is everything we have so far. Okay, the last thing we want to do is figure out what kind of shifting is going on. So this is the hardest part to think about. So I'm going to look at it this way. In January, I have my minimum temperature. So in January, my minimum temperature is, so 1, 2, 3, 4, 5, 6, 24. So here's my January point. Okay, and that's your minimum. In July, I have my maximum temperature. And that's somewhere up here. So what I want to do is I want to make this sinusoidal. I want to make this look like the actual sine function that shifted. So let's think about what happens. So what I would want to happen is it would be 0, 0 here. 1, 2, 3 months later, because that's a fourth of 12, a fourth of the period, I'd hit my max. And then 1, 2, 3, 4, I'd hit my midline. And then 1, 2, I shouldn't be going 4, I should be going 3. 1, 2, 3, 1, 2, 3, sorry. And then 3 months later, 1, 2, 3, I should be hitting my low. And then 1, 2, 3, I should be hitting back. So this is what would happen, like, if life was perfect and I had a sinusoidal function without a shift. But it's not doing that. So the question is, what is the shift of where my max should be? So my max is normally, if I didn't have a shift, my max would be at the 3rd month. But my maximum is here, which is at the 7th month. That's going to tell you your shift. So let me explain it one more time. So if I did not have a shift and I had 12 months, my sine curve would start at that midline, would go to the maximum 3 months later, because a fourth of 12 is 3. So after 3 months, I should hit my max. After 3 months, I should hit my midline. After 3 months, I hit my minimum. After 3 months, I go back to the midline. But with the data that was given to me, I know that my maximum did not occur until July. So my maximum should be occurring in July, but theoretically, it would be occurring the 3rd month. So what is that shift? The shift that I have to make is I need to move right 4. Okay, I need to move right 4 months, which means I need to put x minus 4. Hopefully that made sense. So that's all of my data. So I need right 4. Okay, so what am I going to put in for D? For D, I am going to substitute in 40.1 plus my amplitude, we got 15.9, sine of the B value we got was pi over 6 times x, and I'm moving right 4. When I move right, I make a negative 4. And that is the model. So this is the model that I would use. That's all done pretty much by hand. I might have needed a calculator just to have something or add things together real quick. But other than that, this is done by hand. If I gave you a question like this, I would also want you to find the regression so that you can compare the two and see that your regression is very close to this. They're going to be off a little bit, but your numbers are going to be close. So I'm hoping that that helps. Sorry, I guess I was ignoring something. Okay, I wasn't. I don't think you guys asked me a question. Just lots of like talk on this. So Lucy, regression would be just like we did before, where if I gave you a table, you would be plugging all of this into your table. So you would plug in, you would go to your calculator, go to your table section, you'd plug in 1 through 12 right here. And then under the Y's, you plug in all of this data. And then you have the ability to, just like we had a exponential regression, in that same spot, you have a sinusoidal regression. So you would just go to the sinusoidal regression. I think it says sinusoidal regression. Choose that with this data, and then you should get something very similar to this. So what I got, I don't have my calculator. I'm wicked sorry. Oh, I did not get it for this one. I did for the second one, but apparently I didn't get it for this one. Part A says by hand. No, I just did this one by hand. I'm sorry. But for the second one, so the second one that was in the book, I actually did do it. So I found a sinusoidal function, and when you find it, you're going to find it by hand. Notice that I have it factored. So I found the max and I found the midline, and the amplitude just by taking max plus min divided by 2, max minus min divided by 2. Same thing where I'm going to find the period. And again, this was the monthly thing again. So I did 12 is equal to 2 pi over b, and then found that b was pi over 6. And then I found the shift. And the shift again, apparently your high point is in July again. So the shift was -4. So this was by hand. And then my regression, that's where it says use the graphing utility to find the sinusoidal function of best fit, or the regression, was this. So notice that my midline when I did it myself was 50. My regression was 49. So it's pretty close considering I used 2 pieces of data for this. And then the amplitude, 25.7, 24.95. Pretty close. And then if I were to distribute this, pi over 6 we know is about a half, and 0.48 is about a half. And then a half times 4 is about 2, and 1.8 is close enough to 2. So it's just to compare your data and see. Okay. And that is about it. That's what I was going to do. The third question is just using tides. So you just have to be very careful in the using tides thing where it says it is approximately 12 and a half hours. Okay. So suppose that the length is 12 and a half hours according to the National Oceanic, blah, blah, blah. Again, they're using Alaska. And they use just what 8:11 a.m. is in terms of hours, 8.1833. And then they just ask you to do that. So approximately when will the next high tide occur? Find a sinusoidal function. If I ask you to find it, I'm asking you to do it by hand. And then it says use the function found in part B to predict the height of the water in the next high tide. Heads up though, question 4, because nobody reads the book, even though I ask you to, and I beg you to, you don't read it. Hours of daylight, if there's like a whole paragraph in that section that talks about the hours of daylight and when your summer solstice is and when your winter solstice is. And I think we know that they occur on the 21st of the months. The summer solstice is on the 172nd day, and the winter solstice is on the 355th day. And that's important because your summer solstice is going to be your maximum amount of daylight, and your winter is going to be your least amount of daylight or your minimum. And those are what you're going to need for to find your function here. So they tell you that the summer solstice gives you 19.42 hours in Alaska, not here. And then your winter solstice, you get a measly 5.47. So on the 355th day. So your x-axis, your maximum would be at 172, 19.42, and your minimum will be at 355, 5.47. And again, you want to look for the shift of where that should be naturally. So naturally, you have 365 days. You got to break it up into fourths so that you can figure out 0, 0, a fourth of 365, 2/4 or half of 365, 3/4 of 365, and do it that way. So that's how you would want to do that one. Okay. I'm sorry, I'm ignoring you. Ethan Nelson, it's on Monday. Hopefully you're still there. I think I have E block first on Monday and A block last. It's on Monday. In all caps. Your test could have that many data points, yeah. You mean the monthly ones I use? Because yeah, it can. Because again, if I tell you that it's going to fit a sinusoidal, or it's on the test that it's going to fit a sinusoidal, then you really have to zoom in on just the fact that you're looking for the maximum and the minimum, and that's all you care about. Once you get the maximum and the minimum, you can do anything with them. So, yeah. So you could get a table like the first video. So yeah, you could get one like this. Yeah. Again, once you know that it's just these two data points, then it shouldn't be too hard. And plugging in 1 through 12, I don't think that's going to take you a long time. This might take you like a minute to plug all these data points in, but 1 through 12 should take you, I don't know, 10 seconds. Yeah. In order to verify using a regression, yeah, you would definitely have to plug them all in, but you can do that. It doesn't take you that long. And if it does, maybe you need to practice a little bit more plugging in. But like I said, 1 through 12 should be fast. And then the 24.2, 28.4, that might take you a little bit longer, but it shouldn't take you that long. So yes, you might get one like that. I think I have the answer key to the Chapter 5 review online. I asked a couple of you to just double check that it's on X2 because I haven't really looked at it in a while. I don't even know if you can see this very well. But I might as well. I don't know if are you recording this? Because if you're recording it, then I'm just kind of gonna, maybe if I do that, ooh, that's better. I'm gonna just do this anyway so that just in case. Are you recording it? With sound now. Awesome. So these are just some of the questions. So someone had said, what's a review for the test? And I had said that it's in there, but I don't think everybody did. Define a radian. I'm sorry I didn't put the answer in there, but you already had it on your quiz. Just make sure when you talk about a radian, you talk about the fact that if the radian is defined by using a radius of a circle. So you should have that in your definition. And I think, do I have these ones? Oh, yay, they're way over there. Okay. And then the back side. So I have the satellite. I didn't do the calculator one. I'm really sorry. I'll put those in. And then the graphs, I don't have the graphs on here right now, but I do have these ones. These are just more. And like I said, I put like every answer I can down. So I guess I only did one for 15A, just to determine what the graph is. For B, I think I only put one equation. I just have all my work there. I guess I only did one equation for each of these. I must have been working really fast. But you can double check. I feel like I have more answers on a different answer sheet. I've done these answer sheets a few times now. So those are those ones. No X2? Okay, thank you. All right, I'll look. But they're on this now, so, but yeah, just in case I forget to put them on X2, they are on this video now. So, do you guys have any other questions? I meant it is on there. Okay, good. That's just a quick, like, the lesson in a nutshell of those of you who are going to be missing tomorrow. If you, is this for the BSO that you guys are missing, or is this the field trip, the Shirley prison field trip? BSO. Are some of you going to prison tomorrow too? Okay. So, yeah. I'm done with field trips. Field trips and snow days. I'm done with them both. I think we're going to have school tomorrow. Yeah, you better go to prison if you have school. Hopefully this was helpful for you. This is basically what I'm going to show everybody tomorrow, probably with a lot more questions. But I would love to take a math field trip. If I need to look that up, because the best one I've ever taken kids on, I did it for years and years and years, was to BU, but they don't do it anymore. So I've got to figure that one out and see if there's anything new that any of the Boston schools are doing lately, because that's the best. It was an awesome field trip. Best one you would ever take out of all your high school field trips. So we'll see. I will see you guys tomorrow. If not, have a good day off. And, I'll see you tomorrow or Thursday/Friday. And you guys have a test Monday. Have a good night. I am signing off.